Question 3 is coming from trigonometry part. Show that the equation, this one here, may be expressed in the form, which is the quadratic equation in cosine, where a, b, and c are constants to be found. Those constants can be fractions, can be whole numbers, can be negative or positive. Okay, so here we have 5 cosine of theta, but since this one is in terms of cosine, then where there is sine and tan, I have to express them in terms of cosine. So tan is the same as sine out of the cosine. Then there is plus 1 here is equal to 0. Now since here we have this denominator here, cosine of theta, it is the one that I'm going to multiply all through. So when I multiply all through, this one will become 5 cos squared of theta. Then when I multiply it here, the cosine of theta will disappear. So we shall remain with this one here, which will be minus sine squared of theta. Then plus, of course, this one, when it multiplies with this, you will get the cosine of theta. And then this one will be equal to 0. And then from here, this sine squared theta has to be expressed in terms of cosine squared of theta. So using the Pythagorean identity in trigonometry, sine squared theta is equal to 1 minus cos squared of theta. And here we have plus cosine of theta, which is equal to 0. Then that means we are going to get 5 cos squared of theta. We open the brackets here. What was the negative now becomes a positive, and what was positive becomes a negative. So altogether, this one becomes 5 plus the 1 here. That one will give us a 6. So we have 6 cos squared of theta, then plus the cosine of theta, then minus 1, which is equal to 0. So this is the quadratic equation in terms of cosine of theta. So meaning A is this 6 here, B is this positive 1 here, and then C is this negative 1 here. So that is that. Then part B, they are saying hence, meaning begin from where you have stopped, solve this equation here. And the domain that is given, it is in radians. That means our calculator must be in radians. So we have already got up here 6 cos squared of theta, then plus the cosine of theta minus 1, which is equal to 0. I can use the calculator straight away to solve this one here. I'll go to equation here, then 3 is quadratic, then we can put in 6, then 1, and then negative 1. Then we can see a third and negative a half. So we need to skip some space here, and we write cos of theta is equal to a third, and also cosine of theta is equal to negative a half. Now from here, you need to show the examiner that you have solved the equation. I think you can see that I left space here. So it is for working backwards, you need to show the examiner that you have solved the equation. So the attempt to solve the quadratic equation is always awarded a mark. So first cross multiply here. When you cross multiply, you will have 3 cosine of theta, which is equal to 1. Then bring back the 1. That means we shall get 3 cos of theta minus 1. This is the factor from which this root comes. Okay. The same thing I'm going to do here. When I cross multiply, we shall have 2 cosine of theta, and then let the negative 1 cross. It will become a positive 1. So we have that one there, which is equal to 0. Now, cosine here is positive, cosine here is negative. So we need to find the angles where cosine is negative and also where it is positive. Okay, so the arc cos of a half. Now, I have always used these 4 quadrants if you have been following me. Now, we are going to have 0. Then remember, when we move anti-clockwise, the angles are positive. When we move clockwise, the angles are negative. So this will be 90 degrees, which is pi over 2. This is 180. This is 270. Then by the time we come back here, that will be 360. So if I have the acute angle here, theta, then I also project it this way. That will also be theta, because these are opposite angles which are equal. And also put it here again. then also put it here, theta. That means to move from here to get the angle in the second quadrant, it will be 180, then minus the theta. And then in the third quadrant, it will be 180 plus theta, because this is 180, right? Then plus that theta. And then this will be 360 minus that what? Theta. Now here cosine is positive. Cosine is positive in the first quadrant and fourth quadrant. Actually here, all of them are positive. Only sine is positive in the second quadrant. Only tan is positive in the third quadrant, and only cosine is positive in the fourth quadrant. So from here, since this one here is in radians, then the calculator must be in radians. So what do we get here? The arc cos of a third. My calculator here is in degrees, so I need to convert it to radians. You just press shift, then mod, and then rad is 4, and now shift, then cos, and then I put a third. This one gives me 1.23. That is to 3 significant figures. And then where cosine is positive, again, it is in the fourth quadrant. So I will say 2 pi, then minus that value, 1.23. Okay? I think this one is too congested. Let me just put it here. 2 pi minus 1.23. Then here, the arc cos of this one, the calculator will give you the obtuse angle here, where cosine is negative, and it will give us 120. 120 is the same as 2 pi over 3, because this is 60 times the 2, right? And then to get the other angle, where cosine is negative, it is here. So that will be, when you take this negative here and the calculator gives you this value, just subtract that from 360. So 2 pi minus that 2 pi over 3. Alternatively, you can ignore this negative. When you ignore that negative and you take the arc cos over half, you are going to get the 60 degrees. Are we there? Now, after getting this acute angle, the 60 degrees, now go to the quadrants where cosine is negative. We see it in the second quadrant and in the third quadrant. That means I can have pi, then minus, I'm now here in the second quadrant, then minus this value you have gotten here, okay? So minus pi over 3, or this one here is the same as saying pi, then plus pi over 3, okay? This one here, okay, now let's get our answers. So theta here is going to be equal to, this one is coming from the first quadrant, so I'm going to put them in ascending order. So 1.23 radians. Then the next one is here, which is this one here, 2 pi over 3. So 2 pi over 3. And then the third one here is actually this one. So this will be 3 times 1, that is 3 plus 1, that will be 4. So we shall have 4 pi over 3. And then lastly, we shall have this one here in the fourth quadrant. Okay? 2 pi minus 1.23. That one gives us 5.05. So I will write 5.05. And these ones are to 3 significant figures. So that is that. By the way, in angles, if you don't put anything, we assume that that angle is in radians. So if it is in degrees, always put the degrees. If it is not there, we assume it is in radians. So that is that.